So now we're going to use the first derivative, the second derivative, as well as limits to find out as much as we can about this function. And I'm going to be graphing it last to see if all my work was correct. So we need the first derivative, which is going to be using the quotient rule. For that, the denominator is squared, and then derivative of the numerator times the denominator left alone minus the numerator times the derivative of the denominator. And because this is x squared plus 4, there's no place where the derivative is undefined. So just find out where the derivative equals 0 for the critical values. And a rational function is going to equal 0 only when the numerator equals 0. So we've got negative 2x cubed and a positive 2x cubed. So those are gone. And then distribute the 2x with the 4 is an 8x. So it turns out that 0 is the only critical value. So for the first derivative, we just have 0 as a critical value. And then we need to test something on the left-hand side. So let's see. The first derivative, after we did the algebra, the numerator was just an 8x over x squared plus 4 is squared. Well, this, because it's squared, is going to be positive no matter what. So the only way that the derivative is going to be negative is if this is negative. So this, when x is negative, that's going to make the derivative negative. At 0, we found out the derivative is equal to 0. And if x is positive, then the derivative is going to be positive. So that means the function is decreasing from negative infinity to 0, and it's increasing on the right side, 0 to positive infinity. So I can even use this little number line graph to say the function was going down, then the derivative equals 0, and then it was going up. So that must be a minimum. So there's a minimum at x is 0. And if you go back to the original function and substitute 0, it's going to be a 0 over 4. So there's a minimum at the origin. And that's the first derivative information. Now for concavity, we need the second derivative. So take the derivative of this derivative. So the denominator, x squared plus 4 squared, needs to be squared. So now it's to the 4th. And now do the quotient rule. So take the derivative of the numerator, leave the bottom one alone, minus, leave the 8x alone, and take the derivative of this. So that's going to be a 2 brought down in front and multiplied. In the parentheses, x squared plus 4. Now subtract 1 from this exponent. And then the chain rule says take the derivative of the inside. And like last time, there's no place where it's undefined. We just need to find out where it equals 0. Last time I multiplied it out, but this one, we've got this x squared plus 4 showing up in both of the terms, as well as an 8. So we can factor out an 8 and an x squared plus 4. It's going to leave behind a single x squared plus 4. This 8 got factored out, so we've got 2x times 2x is 4x squared, and this got factored out. So there's a negative 2x and 2x, negative 4x squared. And now that it's factored, all the factors could be set equal to 0. This one would give us no real solutions. So we really just need this one set equal to 0. So combining like terms, that's going to be negative 3x squared plus 4 equals 0. Or if you move the 4 over and then divide by negative 3, the negatives will cancel, and then take the square root. So let's see, the square root of 4/3 and then positive or negative. Or in other words, 2 over radical 3. So that's where it's changing concavity from concave up to concave down. So let's say over here, the negative 2 over square root of 3. Here's the positive 2 over square root of 3. The derivative, second derivative equals 0 there and equals 0 there. Then where is it positive and negative? So it turns out that the second derivative has x squared plus 2 to the 4th for the denominator, so that's positive no matter what. And then it's got 8 times x squared plus 4 right there, which is positive no matter what, times this thing, negative 3x squared plus 4. So really for the second derivative, all I need to do is figure out when is this thing positive and when is that negative, and that's going to tell us where it's concave up and concave down, because this is still going to be positive and positive, so that's not going to change whatever sign this is. So for example, if I use a 0, then this would be gone, it would be a positive 4. So 0 here in the middle means that all of this, the second derivative is positive. And then if I pick something over here, let's see, something bigger than 2 divided by square root of 3. Well, 2 divided by something is going to be smaller than 2, so I should be able to pick, for example, 3. So if I substitute a 3 in here, it's going to be 9, and with that makes negative 27, and with a positive 4, it's going to be negative. So this, and I could also over here use negative 3, and with a negative 3 in there, it's going to turn out to be the exact same thing, because a negative 3 squared is 9, times this is negative 27 again, so the result would be the same. So it is concave up in the middle, so from negative 2 over radical 3 to positive 2 over radical 3, that's concave up. Concave down on the left hand side, from negative infinity to the negative 2 over radical 3, together with the right hand side, 2 over radical 3 to positive infinity. This one did not ask for inflection points, but these are the x values for the inflection points. And then concave up, concave down, minimum, maximum, increasing, decreasing. Any asymptotes? Well, vertical asymptote would happen if this was undefined, and x squared plus 4 is never going to equal 0, so that's not going to happen. The other one is horizontal asymptote. So take the limit as x goes to infinity to find out, does this function level off? And since x is going to infinity, plus 4 doesn't really matter. You've got x squared divided by x squared equals 1. Or you could use L'Hopital's rule twice and you end up with the same thing. And so there's a horizontal asymptote, y equals 1. There are all of the pieces asked for. And now, take a look at the graph. So there's the function. Here's the graph. Sort of a boring looking little graph there. I think I'll zoom in, change the y values a little bit, -1 to 2 or so. It looks like something bounced off the ground. Boing. So let's see, there's a minimum at 0, 0. Got that right. It's increasing on the right, yes. It's decreasing on the left, yes. And then check these points. So just by taking a look at this, actually it looks like it changes right about there to me. This is concave down, and this, I guess, is concave up. Let me see. X equals 2 divided by the square root of 3. Okay, so this middle part, which looks sort of V-shaped, is actually U-shaped. So this middle part is concave up. That's what this was telling us. And then this is arced down. Even though it's increasing, it's going up, but it's doing it in an arc down fashion. So this is concave down, this side's concave down, so the two outside ones are concave down. We got that part right. The last thing to do is have this go out to, let's say, 50. And see, does the function level off? So according to this, it's going to level off at a height of 1, which looks absolutely right. There's all of the parts.